So far, we've explored several different variable types which represent all different ranges of values. However, despite all the differences, they all have one major thing in common, and that's the fact that they can only ever store or represent one value at a time. What if there arises a situation where we want to store multiple different values within a single variable so that we can pass these values around with ease? There's a few different ways we can do this. One way might be to declare some kind of a collection type, such as a list or an array. This isn't a bad way of doing things, but lists and arrays are generally better to represent larger collections of numbers or strings or whatever type we declare. As well, they're generally restricted to a single type, so let's say we wanted to pass around a number and a string within a single variable. Well, a list might not be the best way to do this. As well, lists and other collection types pack a lot of additional functionality and so can be a little bulky, a little cumbersome for the purpose of only carrying around a few values. We could also create some kind of an object through a struct, class, or enumeration, but again we run into the same issue of it being a little cumbersome and just a little unnecessary to pack around that much hardware within a single variable for just a couple of values. So the next best option would probably be to use some kind of a tuple. And that's what we're going to be covering in this section. So tuples, or tuples as some people call them, are essentially variables or constants that can store multiple different values. Now the beauty of these is they're pretty lightweight and easy to use, and also they can store multiple different types at once. So we could store, say, a number and a string and a Boolean value all within a single tuple. Okay, so that's what we're going to be focusing on, is how to declare and use tuples, and then there's going to be actually several ways we can retrieve values. We're going to explore all of them within this section. So let's first take a look at some simple tuple syntax. And I'm going to call them tuples, some people call them tuples, but just know that we're representing the same thing here. So we start off the same way we would, declaring a variable or a constant with var or let. In this case, I'm just going to declare this to be a constant. I'm not going to change its values at all. So I'm just going to declare a very generic type and leave it in a comment, and then we're going to look at some specific examples. So we would have the name. Actually, I'm going to say var/let. Then we'll have the name. Okay, we can have the type. I'll go over this in just a second. And then we have equals, and then whatever values we want. So we could have value 1, value 2, etc. And in here, for the types, we would have value 1 type, and then value 2 type. Okay, now I'm just going to leave this as a comment because this is going to throw us errors. And this is the general setup for a tuple. So again, as always, the type is actually optional. So we can omit that if we want, but we do have to have this in here. It does have to have some kind of a value. So some similarities and some differences. The major difference is that the values are placed within parentheses because there are usually multiple of them. We could store just a single value within a tuple, but it's a little unnecessary, as we might as well just represent that with a regular variable. So let's turn to a specific example. I'm going to keep this game example running, so perhaps we have a character who has an inventory full of items, and so each of those items should have a name and a value. And that value is going to represent a kind of quantity of the item. Now each item can have a lot more fields than this, and it might be better represented with a class, but we'll talk about that a lot later. For now, all we want is a name and a quantity attached to our item. So each item should probably have a string to represent the name, and some kind of an integer or other number variable to represent the quantity. Well, this would be a great place to use a tuple, because we want to keep those two values together. So what we could do is we could say let, and I'm just going to call this item. Okay, and we'll declare the type in just a second. I'm just going to pass in a value. In this case, we can have some kind of a string and then an integer. Let's have the string be something like food. Perhaps we have some food in our inventory, and we have 3 of these food items. Okay, so now we've stored 2 different values, and note the different types as well, within our single tuple. Now if we were to assign this a type, we have a string and an integer. So we just bundle these together in parentheses like we see up here. So let's give this a type of string and int. Okay, and again, once a type of a tuple is declared, we cannot change that. Also, as we've declared the type here explicitly, we can't add additional items to this tuple without also changing its type. Now I've only added 2 values here, but we can add as many as we want. However, past a certain point, you probably have to start to wonder, should I use a different data type to represent this? And if you have many values, then probably yes, some kind of a collection type or a structure would probably be better. However, if it's just a few values, a tuple works just fine. So let's talk about how to retrieve values from within a tuple, and there's a few different ways. So one is by accessing the elements of a tuple by index, so we can treat it like a collection in that sense. The second way would be to explicitly decompose our tuple by pulling out the values and storing them within constants. That'll be a little more complex, so we'll cover that second. And then the third way would just be to give each of these values a name and then call on the name. And that's going to be a little more complex than previously, so we'll cover that last. So let's focus on the index first, and actually you can kind of see what's going on here if we take a look at our preview. So you see at .0 we have food, and .1 we have presumably our number 3 here. So let's pull these guys out, and we're just going to store them within some constants. I'm actually going to call this item 1 because I'll probably add another item later on. So we're going to pull out the item 1 name, so item 1 name is going to be of type string. Again, we don't have to declare it as such, but we will. And we're going to set this equal to item 1 dot, okay, and notice how there's two options here. So the first is 0, second is 1, and these tell us the types that they're going to return. So in this case, item 0 or item 1.0 would return food. So you should see in just a second, item 1 name will pop up with the value of food here. Okay, similarly, we can get the quantity, and there it goes, by saying item 1 quantity, okay, of type int is just going to be equal to our item 1 dot 1, so the item at index 1. In this case, it's going to be number 3. Now keep in mind that indexing is 0 based, so this is technically index 0, this is index 1. Okay, so as you can see, it's stored food and the number 3, so it looks like everything is good. So that's how to access our tuple elements by index. So if you had something at index 2, 3, 4, etc., you'd do exactly the same thing. Now let's pull out items by assigning them names rather than accessing them by index. So we can do essentially what we're doing here, but all within one line of code. So what we can do is create an additional tuple here. Well, it's not exactly creating a new tuple, it's just a way to pull out the values. So instead of saying item 1 name equals item 1.0, item 1 quantity, item 1.1, we can actually declare the names of the constants we want to use, or variables if we don't want to use constants. And we can do this right within the parentheses here. So I'm just going to simplify things. I'm just going to say name 1, okay, and quantity 1. And I definitely spelled that wrong, quantity 1. Okay, and I'm going to set this equal to item 1. Okay, it's really just as simple as that. So now what we're doing is, because item 1 is a tuple with only 2 values, we're essentially saying, okay, the value at index 0 we're going to store within this variable or constant, and the item at index 1 we're going to store within this constant. What we couldn't do is then add additional names. You know, if I put some garbage name in here, it's going to give us an error because it's saying item 1 only has 2 values right here, food and 3, and so there's nothing to store within this one. However, if we get rid of this, then we should see that name 1 will store our value food, and quantity 1 will store our value of 3. So if I were to call on name 1, and let's just let playground run and print out the value here, you see food here, and then same with quantity 1, not item quantity 1 actually, we just want quantity 1, and it should pop up with a value of 3. So let's just let that run, and okay, I guess we won't wait for it to run, it's being a little slow. Okay, but we're essentially doing exactly what we did up here, but in just the single line of code. So it's just kind of a little bit of a shortcut. Now this way is a little more explicit, a little more clear as to what's going on, but this way is just fine. The nice thing about doing things this way is we can choose to omit single values as well. For example, let's say I was only interested in the first item in our item 1 tuple, so all I want is the string, I don't want to bother storing the quantity. Okay, so what I can do is I can just say let, and then I'm just going to call this name, again a slightly different name, and then what I can do is I can add in the underscore to say I'm not interested in the quantity this time, and I'm just going to set this equal to item 1. So now what this is doing is we're saying essentially, I don't care about the second item in our tuple. Okay, I'm only interested in the first item. So that's why we put the underscore in here to tell the compiler we're not going to focus on the second element of this particular tuple. So we're just going to essentially store the name of item 1 or the very first item in our tuple. So then if I print out name, not name 1, we just want name, it should again come up with the value of food. Similarly, we can do things the other way around and just say let underscore and then the comma and then quantity, can't spell that word right for the life of me, so it's just going to be equal to item 1. Okay, and this is essentially now omitting the first value, and we're just interested in the quantity of this particular tuple. So just a few different ways of doing essentially the same thing. Now the third and final way to retrieve values from a tuple, and I know we all like different ways of doing the same task, is to assign our variables, I guess here, actual names at the declaration. So what I mean by this is, well, let's first start by creating a new item. So I'm going to call this item 2. Let's say we have some kind of matches, so I'll give it a type in just a second. And again, we're going to keep with this string int, string and int theme, okay, because I think the name and quantity is appropriate. This time we're going to have matches, and there's going to be, let's say we have 10 of them. So rather than just leaving these values without names, what we can do is assign names to each of these values. So if I want to say item name matches and then item quantity, and again spelling it wrong, then what this is doing is it's saying, okay, well, item 2 now has 2 explicit variables or constants attached to it. So now what we can do is simply call on item 2 dot, and then we can call on the item name here. Now actually, in order to be able to use this method, we don't include a type. So if we actually omit the type, then that'll get rid of the error. So let's try this again. So if we do item 2 dot, now we should see instead of the indices popping up, so 0 and 1, we actually get to choose the items by name. So this is perhaps a better way of doing things because it makes it communicates the point we're trying to get across a little clearer. So now we know exactly what each of these values is representing rather than just having the type and then accessing by index. So we can just store this within some kind of a constant. We can say let our item 2 name or something equal this, and then we can say let item 2 quantity, almost spelled it wrong again, item 2 dot item quantity. Okay, so it's essentially again doing exactly the same thing. It's just this way is perhaps communicating your point a little clearer. And we do want to be as clear as we can as often as we can. So although this way might be a little quicker because we don't actually have to explicitly declare the type and we don't have to name our values here, it's better to do this when we have the time and can put in the effort. Okay, so that just about sums up our topic of tuples. We will see examples of tuples being used within stuff like functions, passed around as parameters and so on and so forth, and return types. But just know for now that tuples are an excellent way to store just a few values, and again, it's not a good idea to store many values, just a few that go together. It's a really great way to associate those items that are related and store them within a single variable or constant. And as we've seen, there's a few different ways we can retrieve our values. So at the end of the day, it really just comes down to personal preference. Okay, so our next topic is going to be on the topic of conversions between our types, and then if we get time, if we have time, we can also talk about typecasting as well.